Morning to everyone. In this video, I am going to discuss about the analysis framework. Previous video, we had discussed about a specification of an algorithm. Now I am going to deal with the analysis framework of an algorithm. So here, I have written the algorithm for multiplication of two matrices. So what are the two different framework is? One is time complexity and another one is space complexity. So here time complexity and space complexity we need to perform for a certain algorithm. So here algorithm multiplication, A is A matrix, B is another matrix, N is the dimension. Normally whenever I am going to perform multiplication between two matrices, it must be n by n, so equal to n square. So here for I equal to 0, I less than n, I plus plus. Next for j equal to 0, j less than n, j plus plus. C of ij equal to 0, k of k equal to 0, k less than n, k plus plus. C of ij equal to a of c of ij plus a of ij star b of ij. Then the value will be written. So in those case, you should have to remember one thing, that if I am writing an algorithm for if any variable used on the left hand side, if the same variable is used on the right hand side, then those variable must be initialized. So here c of ij equal to c of ij plus a of ij star p of ij. So c of ij is used on the left hand side as well as the right hand side. So I am initializing the variable. In this algorithm, the first for loop, for I equal to 0, I less than n, I plus plus. Here how many statements are there means 3 statements. One is initialization, another one is condition, another one is either increment or decrement. The I plus plus statement will be executed n number of time, as much as n, according to that it will be executed. I equal to 0 will be executed one time, but I less than n will be executed n plus 1 time, provided the condition will be keep on checking out for true value, and at last it also need to check for false value. Once if it is false, then it will terminate the loop. So here I plus plus is for n times, I less than n for n plus 1 time, I equal to 0 for 1 time. So among all those things, n plus 1 is the biggest one, so I am choosing for n plus 1 number of times. Then next j equal to 0. Here we must always remember that whatever be the statement come under the for loop will be executed as much of time as the increment part or decrement part is executed. So in this for loop, I plus plus is executed n number of time. So what are the statement come under the for loop will also be executed n number of time. So j equal to 0, j less than n, j plus plus also n number of time. C of ij equal to 0 also n number of time. K for loop is also n number of time. Computational part is also n number of time. Then next I am considering about the next for loop. The next for loop I have j equal to 0, j less than n, j plus plus. J equal to 0, 1 unit time. J plus plus will be executing n number of time. J less than n will be executing n plus 1 number of time. As I said before that, the whatever be the statement come under the for loop will be executed as much of time as the increment part is executed. In this for loop, j plus plus is executed n number of time. So under those things, whatever be the statement will be executing n number of times. So again I am multiplying that initialization c of ij equal to n number of time, k loop also n number of time, computational part is also n number of time, but this j loop will be executed n plus 1 number of time. That's what I have written, n star n plus 1. Next the c of ij equal to 0 will be n star n time. Then k loop, here I have 3 different statements, k equal to 0, k less than n, k plus plus. As I said before, k plus plus will be executed n number of time. So whatever be the statement come under this for loop will also be executed n number of time. So again I am putting a star n for the computational part, and this loop will be executed n plus 1 number of time. For computing the total time complexity, I have to sum up everything. So n plus 1 plus n star n plus 1 plus n star n plus n star into n plus 1 plus n star n. So totally 2n cube terms are there. So 2n cube plus 3n square plus 2n plus 1 is the total time complexity. In terms of polynomial, when we are representing it, it will be order of n cube. This is the concept for identifying the time complexity. And in case of space complexity, we have to find out all the variable. Here A, B, C are the three different variable. Apart from that, I am using I, J, K, N. Those are the variable. A, B, C are the matrices. So A will require n by n star n matrix. B will require n star n, C will require n star n. So all those things will have n square. So A will have n square space complexity, B need n square space complexity, C needs n square space complexity. So n square plus n square plus n square 3n square plus I will require 1 unit space time, J will require 1 unit space time, K will require 1 unit space time, n require 1 unit space time. So everything will have 1 space time. So the total space complexity for this algorithm is 3n square plus 4. Next, for this loop, simple loop, I am going to find out the time complexity. For I equal to n, I greater than 0, I minus minus. In the previous case, we have discussed about I plus plus plus, but here I am discussing about I minus minus. I equal to n will be executed 1 unit time. I minus minus will be executed n number of time. So whatever be the statement come under this for loop will also be executed n number of time. So the statement will be executed n number of time. Whereas I greater than 0 will be executed n plus 1 number of time. So I am going to consider n plus 1 number of time for this for loop. So total time complexity will be n plus 1 plus n, that is equal to 2n plus 1. So in terms of polynomial, f of n is equal to order of n. For this program, here I am going to increment the value by 2 always. So if I am increment the value by 2 always, then the number of execution time will be reduced. For example, 10 means 5 times the loop can be executed, it's enough. 4 means 2 times the loop can be executed, it's enough. So according to that, it will be executed n by 2 number of times. I less than 1 will be executed n plus 1 number of time. So when I come add together, I may get n by 2. So the polynomial f of n is equal to order of n. When I discuss about while loop, what will happen here is I equal to 0 while I less than n statement I plus plus close the curly brace. Here first I have to check the condition. When I am checking out the condition I less than n, it will be executed n plus 1 number of time. Then increment the value I plus plus will be n number of time. Statement also will be n number of time. I equal to 0 will be 1 unit time. So when I add up all those things together, I will get 3n plus 2. So f of n is equal to big O of n. In this program, it's somewhat very interesting. A equals 1 while A less than or equal to B statement A equal to A star 2. Each and every time the A value will be the power of 2. Because A equals 1. So when A equals 1, in this program we cannot identify the value of B. So we don't know when the algorithm will be coming to an end. But algorithm means it must have to come to an end. Finite number of times only the algorithm need to be executed. So according to that principle, first A equal to 1 means this execution part A equal to 1 star to 2. Then A value will be increment means next iteration what will happen? A equal to 2 star 2. 2 star 2 means 2 power 2. Again A equal to 1 value 2 power 3. So what will happen? 2 power 2 star 2, 2 power 3. Keep on the loop will be executing with the power 2. So where it will stop means the algorithm will stop. We have to assume that the power k. So 2 to the power k. When it reach 2 to the power k, the algorithm will stop its execution. But when I check it out the condition, when a less than or equal to b, keep on it will be executing. When it will be not executing means when a greater than or equal to b. When a greater than or equal to b, the following statement will not be executed. So a greater than or equal to b means here previously I have checked out 2 to the power k. When the algorithm reaches, then it will stop. A greater than b means also it will stop. So I am assigning a for 2 to the power k. So 2 to the power k is greater than or equal to b. Here equal symbol is there, so I can write 2 to the power k is equal to b. In mathematics we have discussed so many times, a power n is equal to x means we will write log x to the base a equal to n. According to that we will write k equal to log b to the base 2. So now the time complexity will be log n. This is all about time and space complexity. Thank you.